All right, perfect. Welcome everyone to day one of Installfest. Let's go ahead and break down our curriculum first. This is the first time you guys have seen our GitHub organization. You will have access to this here shortly. We'll go ahead and post this curriculum repo inside of your bookmarks for the Avenger channel once we finish collecting all of your GitHub Slack handles. So please make sure that you add your Slack handle into that thread that Adam posted in the Avenger channel. Now, here you'll see all of our separate modules that we'll be learning over the course of the next 15 weeks. In this week, we'll be concentrating in 01 JS Python intro. And this also correlates with our YouTube channel. If you look for 01, that's going to be the playlist that covers this exact module. And as follows, for our second module, we have object-oriented programming. Third module, we'll start diving into AI and LMs. This might change a little bit within the next few weeks. And then we have our full stack and so on, right? All the modules are there, numbered along with each individual day that belongs to each module. So you'll be able to see everything. Should be pretty readable for everyone. But if at any point you have any questions on how to maneuver around your GitHub, the GitHub organization, please just let us know and we'll make sure to get back to you as soon as possible. So here we are inside the JavaScript and Python intro. And today it's going to be our very first day going into Installfest. So this is actually the lecture that we'll be diving into. If you scroll down, you'll see Installfest. There's going to be a what are we trying to accomplish if you want to just read through that before the class starts. There's going to be terminal learning objectives, which is individual things that you're going to be actually tested on. And then there's enabling learning objectives. Not necessarily something that you'll be tested on, but more something that you should know in order to succeed in this program. So let's go ahead and dive into our very first lecture here. So in our lecture of Installfest, there's this whole computer setup. We're not going to dive into that just yet. We're going to break down Linux commands and how that works first. So here we have this intro to Unix. Can somebody read this two paragraphs here?
What is Unix? Whether you are on an actual Linux system, Mac OS, or Windows with WSL, we are going to refer to all of these environments as Unix, or just the command line interface, CLI for short. So what is Unix? Without getting too deep into the weeds early on, Unix is an operating system architecture and set of tools that allows a user to interact with that operating system through a command line interface. It is a lingua franca of operating systems, i.e., it is the language you can expect almost any operating system to speak and allows you to interact with it in a predictable way.
Awesome. Thank you so much. So there you go. That's Unix. We'll break that down here in more detail shortly. Let's go ahead and break down everything else first, and then we'll come back to it. Can somebody read through the details of Unix here?
In reality, Unix started as a specific OS invented at Bell Labs in the 1960s by some of the same people who invented the C language. It was very popular, but also open source, so different operating systems copied the concept. However, there was poor compatibility between different implementations, a common theme in the history of software development. Complicating things further, software used to be deeply coupled with hardware and made to fit it for an individual project. So even within a given company, there wasn't a single OS that unified the experience across devices. That changed in the 80s with the invention of the personal computer and Apple and Microsoft becoming the most significant players in that emerging market. Mac OS based its OS architecture on Unix, whereas Microsoft went its own way entirely with Windows and MS-DOS. Then in the 90s, Linux was invented as an open source operating system and defined the core kernel that all other Linux distributions or flavors are based on. Linux is odd in the sense that it is open source, so there isn't one Linux. There are a few popular flavors, but a million others that are just as legitimate, just not as widely used. That means that in the modern age, we have
All right, and I'll take over at this point. All right, so we just went over the history. Essentially, there was a whole debacle where people were trying to make individual languages that can speak to software, right? And they were very tightly coupled with everything that was actually happening inside of that machine, which meant that every language for every machine was kind of unique in its own sense. Well, that created a problem, right? Because that meant that one person had to know multiple languages to be able to utilize multiple different facets of a machine or of building an application. So how do we fix that? Well, they came along into actually creating a different language that would be able to speak to all of the different software or and hardware out there in a more universal language, and that became known as Unix. Now, Unix eventually grew into something called Linux. And Linux is now the most commonly used language, but there's different flavors of it. So we're kind of going backwards into creating the same issue where, yes, we have Linux, but now there's different versions of Linux that is being utilized at different levels of software. So here in WSL, you'll be utilizing Ubuntu, and then for Mac, you'll be utilizing Unix. So here we have Linux, which is a most closely based on Unix, but may differ slightly based on the flavor. So here we have Ubuntu, and then there's Debian. For those of you that are going to be utilizing WSL, again, you'll be in Ubuntu. For Mac OS, we have a Unix-like system. It's not exactly like Unix, but it's pretty close to it. And then there's Windows, which Windows has its own entire thing. Um, Windows utilizes PowerShell, and that has completely different commands than most of the Unix stuff. So to accommodate that and to make sure that both or everyone here in this classroom has pretty much the same environment, what we're going to do is we're going to have Windows user install something called Windows Subsystem for Linux. Short is WSL. And what that's essentially going to do is it's going to install a mini interpreter inside of your machine so that you could interact with your machine utilizing Linux commands instead of utilizing PowerShell. All right. Now, let's go ahead and talk a little bit about architecture here. So here we have applications, shell, kernel, and hardware. Now, what we're used to seeing, or if you're not experienced with programming, what you're used to seeing is just an application. Simple things that you click throughout your screen and then things opened up, right, inside of your machine. Well, inside of those applications or applications themselves are ran by hardware and software, right? The hardware being everything that makes the lights turn on inside of your machine, how much of the screen it's actually occupying, the screen being able to show individual lights, memory space that's being utilized inside of it. We're not going to dive too far into hardware just because that's a very in-depth level, but your application isn't just something that magically happens, right? It has to be able to talk with your machine. The machine itself, or the brain of the machine, would be the kernel. And then the hardware is more of like the body of the machine, right? But we need a way for this transformation or for this information to be transferred both inboard and then outboard. So there is this circle-like drawing. I like to break it down a little bit further. All right, so we have our machine here. And you're going to see me use TL draw law. Please don't make fun of my drawings. All right, so here we have our machine. And inside of my machine, I may have an application, which is what shows on my screen. So I have my application. But my application lives inside of my machine. My machine has its own separate brains, which is the kernel. And then I have the hardware, which is the body of my machine. Now, we know that the brain of my machine can talk to the body of my machine. But how does my application, or how does an application speak to these two, right? Well, that's where our shell comes in. Or we could just call it a middleman, right? Where the shell works as an interpreter that interprets Linux or Unix commands to the kernel. So I click on my application starts running a bunch of code that gets executed by the shell. The shell talks to the kernel, says, hey, this is what I need to happen. The kernel listens to the shell. It runs all of that, make sure that it has everything that it needs to do to be able to actually run the application. And then it starts talking to the hardware. And all of the body of the machine starts actually interpreting that code, right? Lights start turning on, individual ones and zeros start happening, gateways start opening and closing. So then it goes back, and now it goes all the way back to the shell saying things were successful. I get outputs. The most common thing that we've seen so far is maybe something like hello world. But when you open up an application, it's actually opening up some sort of user interface that shows up in the screen. And then we have our application up and running, right? So that's kind of the flow of information as it goes down. Here we can see it as a circle. The application is the surface level, which you interact with. The shell is what interprets the software of that application. The kernel is the machine actually going through that code and turning things on by speaking to the hardware. Once things are on, it goes back to the shell. The shell receives outputs, and that output goes to the application. All right, so it's just a trickle-down effect of how the machine works. Now, that is very surface level. There's definitely a lot more in-depth detail there. But that's just the very top layer of how this is going to work. Does anyone have any questions about that? Okay, I don't see any hands raised, and I don't see anything on the Avenger channel. So let's go ahead and keep pushing forward here. All right, this is going to break down everything that I just said. So let's go ahead and continue moving here. All right, so now we have files and folders. How does this work? Let's go ahead and start talking about this in a desktop fashion. So inside of my desktop or inside of my machine, there's no actual, I know everything looks nice and pretty and we have a nice user interface, but everything inside of your machine or your computer is just files and directories. I'm not going to call them folders. So instead, let's go ahead and make something here. A folder is a directory and a file is just simply a file, right? We're not going to call them anything different moving forward. So we have directories and files. So inside of your machine, you'll notice that if you were to open it up, what you have is a directory for your user. Inside of that user directory, let me open this up again. Oh. So here we have our machine. Here we have our user directory. Inside of that user directory, you're going to have something like a desktop. And inside of that desktop directory, you're going to have any folder or file that you may have on your actual desktop being displayed. Maybe you have something like family pictures, a folder holding all those pictures, right? And then finally, inside of said folder, you'll have files, where each independent file may just be a .jpeg, it may just be a txt file, or one of the many different types of files that you can store inside your machine. Now, not only is there a desktop, you may also have something like downloads that also holds nothing but directories and files inside of it. You're going to hear me say this a lot throughout the program, but everything inside of what we're going to be teaching and also inside of your machine, the easiest way to think about it is just a Russian doll. There's a bunch of boxes inside of boxes. And the more you open it up, the more dolls that are going to come out. And it just never stops. Right? That's all it is. It's just boxes inside of boxes. You'll see the machine, there's the user, the desktop. And if we want to take a look at that, before we start going into commands, I'm just going to quickly demonstrate here. If I were to go into my user directory and I run ls, you'll see that I have a bunch of different applications here that I've been working on. But here at the very top level, I have desktop, I have documents, downloads, a library, movies. These are all the different directories that are at the user level for the user Francisco Avila. But if I were to go even one more back and run ls, you'll see that there's different types of users. So if you have multiple users inside of this machine, they would all be listed in here. You could even go another one back. And here you'll see at the very root of your machine, there's things like applications, library systems. Now, these aren't applications that belong to the user. These are applications that belong to the machine itself. So these kind of applications are the applications that actually run your machine. When you click start, things like your fingerprint being scanned and actually opening up your machine, that all falls inside of those applications, right? And then you'll see that there's users, there's other things here that we really won't touch. Just know that this is the very root level of your machine. We're not going to go into Linux commands just yet. Just wanted to break down how those files and directories actually work. All right. I've gone over quite a bit of information here. I'm going to go ahead and take a pause. Does anyone have any questions or anything that I've covered up to this point? Okay, there are no questions, so let's go ahead and keep moving forward. All right, so now we've talked about machines and all the files and directories. Now let's start going into commands here. All right. So here I'm in VS Code. I'm going to simply create, I'm inside of our Installfest directory. I'm going to create a file. I'm not going to go in order as to what we have here inside of our curriculum because it's not necessarily natural as far as how it would be best to present it. So let's go ahead into the presentation portion. I want to create a file. Now I could right click and say, hey, I want to create a new file. All right, I can come here. There's even a button to give me an interface to create a new file, but we're programmers now. So there's no reason that we should be utilizing a user interface when we know the simple Unix commands, right? I have access to my terminal, and my terminal is what allows me to execute actual Linux in my machine. So I want to create a file. Well, there's no command like create file. That's just going to give me an error. Instead, the command to create a file is touch. And what I want to create is a readme.md. And MD stands for Markdown. You'll notice that now inside of my Installfest directory, I have a file called readme.md, which is exactly what I asked it to build. Now I want to open this readme. If I run open readme, let's see what that does. Well, it didn't do anything in this case. I believe it's opening it up in a separate application. It is opening up a separate application. But instead, because I want to see it in VS Code, what I'm going to do is I'm going to execute code readme.md. And that will allow me to actually write inside of my readme file. You'll see that my readme file is now open, and anything that I enter into this file will only be registered inside of this readme. So here I'm going to go ahead and do a little bit of formatting. I'm going to call this Installfest, and I'm going to add a couple of notes. So my first note here, we know that touch is utilized to create a file. And we know that code plus file name is utilized to open a file in VS Code. Now we just talked about directories and how all files belong inside of a directory. So if there's a command to create a file, there must be a command to create a directory. Well, this command is going to be make directory or make dir. And I could just name it anything that I want. And here I'm just going to go ahead and name it example 1. And now you'll see that there is an example1 directory. So here we have McDeer plus name of directory creates a new directory. All right. Now, how do I go in and out of this directory? Well, there's a command called change directory. So I'm going to cd, which is change directory, into example1. And by doing so, if I run the command ls, it will show me everything that's inside of example1, which as of now, it's empty. So let's go ahead and do that. We created a directory. We know change directory followed by name of directory. We'll enter child directory. And it's better to annotate it now. Change directory ... will exit child and enter parent directory. So for example, the parent directory of example1 is Installfest. So if I wanted to go back to Installfest, I could simply do cd ... And that takes me back to 1-installfest. And if I were to run ls now, which stands for list, it shows me that I have a file named readme.md and a directory named example1. So let's go ahead and go into that. ls will list all existing files or directories. Let's just do and directories within current directory. All right. So we just covered quite a bit of commands here. Does anyone have any questions over these commands? These are going to be probably the most common commands that you'll utilize throughout this cohort. Let's hear Andy.
I've tried to do the code to open with a file VS Code. It's giving me the command is not found. Am I missing something from installation?
This is likely going to be due to the Installfest. Once we go over Installfest, we're going to cover over how to get that command working for you.
Okay.
Awesome. Anyone else? Okay, perfect. It doesn't seem like there are any other questions. So let's go ahead and continue moving forward here. Now, we've seen all of these different commands up to this point. So let's put some of them into practical application. Can somebody walk me through the process of creating a file named main.py inside of my example1 directory? How could I do that?
You can do touch space main.py.
Want to navigate to the directory first,
Yeah.
or include that in the file name.
Awesome. So I see somebody said to include it within the name. So I'm assuming you're saying to include the directory example1 slash main.py. And you'll see that I created it. Now, why did I have to add that example1? When I do touch followed by the name of the directory, or excuse me, followed by the name of the file, what it's going to do, it's going to create it exactly in that location. I can also specify a path to new file location. So in this case, the path that I specified is, hey, inside of the example1 directory, I want you to create a file named main.py. Now, the other example was to enter this child directory. So I could do change directory example1. And I could have created something like main.js. And now I have main.js inside of example1 and main.py inside of example1. All right, awesome. How could I list all of the items inside of the directory example1?
ls enter.
Perfect. Yeah, I could just run ls, and that would show me my two separate files inside of example1. All right. So now we got a little bit of practical application here. We were able to enter a directory and create some stuff. Let's take a look at what else we have here. All right, so we have PWD, which stands for print working directory. If I ever wanted to see my entire path, so let me go ahead and write this down. PWD will demonstrate, or excuse me, will output entire path to current location. So for example, currently we're inside of example1. But where does example1 live? Well, if I run PWD, it's going to tell me, hey, inside of my root, so inside of my machine, there is a directory named users. So let's take a look at that. Here's inside of my machine. If I run ls, there is in fact a directory named users. So I could cd into users, right? And then it's saying inside of users, there's a directory named Francisco Avila. So again, I can say, all right, cd into Francisco Avila. You'll see that path is starting to get built. Then it says inside of desktop and inside of Avenger, demos and nodes. So I can change directory, and I'm going to tackle both of those at once just to save us some time. Desktop, Avenger, demos and nodes. All right, so now I'm in Avenger, demos and nodes. Then finally it tells me inside of the directory, -intro-py-js, or excuse me, -py.js, and Installfest. So let's tackle both of those. cd into -intro-py.js, and then -installfest. Finally, it says there is a directory named example1. So cd into example1. Now I'm inside of my current directory where I'm currently living. And that's how I get my entire path to print my current working directory. Now, why would this be useful? Well, this comes in super handy whenever you're building or you're referencing absolute, and we'll cover this later on, absolute paths to separate files. I promise I can stop within applications. It can also be useful when working on deployment environments and referencing absolute paths. All right, so that's the PWD command there. We have ls, which we already covered, and then there's this ls-a. ls-a is actually going to give us some hidden folders. So if we go back here to Avenger, demos, and nodes, if I currently run ls, all I see is -intro-py-js. If I run ls-a, you'll see that I get this dot and this dot. Well, what are those? If I go to cd period, nothing really happens. I'm still inside the same directory. If I go to cd ... that just takes me back one. Kind of works like a linked list there, where it's keeping track of both of those. Now let's go ahead and add a couple more things here. If I run something like git init, it's going to create a couple of other files. Again, if I run ls, nothing really happens. But if I run ls-a, now we're going to see a .git directory that also lives inside of my file. This dot or any dot directories are going to be hidden to the user interface, and the only way to see them is through ls-a. So ls-a, which stands for list all, will show hidden directories within current. All right. Does anyone have any questions over those two commands, ls-a and pwd? Okay, perfect. If there aren't any questions, let's continue moving forward. All right, we've covered change directory. Here's a little bit of hierarchy here. So change directory / will take you to the root of your system. So let me do that here. So cd / goes to root of machine. Change directory tilde goes to root of current user. All right, so there's two of those. These two would come in handy if you just want to go back to your root directories for either your machine or your user. Usually you always want to go back. Most of the time you'll end up going back to your user. So that cd tilde does come pretty in handy. All right, and now we have absolute versus relative paths. Great. So let's start breaking that down. So now, absolute versus relative paths. So now, important key of information to note here is both of these are just paths, and they are different ways to establish a path from one location to another. Now, if you want to make something flexible, relative paths are usually preferred. Now, why is that? Well, flexibility. Well, that is because when you create applications within your own machine, an absolute path would include your local machine's information. Well, when you're sharing code or deploying code, your local machine doesn't exist. By creating relative paths, it only includes paths relevant to the application, excluding your machine information. All right. So now if we take a look at an example of a relative path, currently I'm inside Avenger demos and notes. Well, if I wanted to enter example 1, what I can do is I can say change directory from this directory. So that period means from this current location / I want you to enter 1 - intro to JS and Python -1 Installfest, and then example 1. All right, and I can even reference a file here, such as main.py. This is a relative path. It is in relation to the directory of Avenger demos and notes. And it comes from one specific location already within the application. Now, an example of an absolute path. An absolute path would be something like running pwd. Right? Print working directory includes my machine. It doesn't start from a specific location like it does here. Instead, it starts from the root of the machine. Well, this could be an issue because when I go into a deployment environment or I share code with somebody else, inside of the person who I'm working with, there's no such thing as a user, Francisco Avila. If I were to share code with Adam right now and give him this path, it would throw an error saying that this path does not exist. All right, Francisco Avila doesn't exist inside of his machine as a user, unless at some point he let me utilize his machine and I logged into it. Now, if I were to share code with Adam and I shared a relative path like this, then it would work because it would say, hey, from the current location, I want you to enter the following files. It is relative to the application that I am sharing. And that's the difference between relative and absolute paths. Absolute is from the very beginning, so from your machine, the entire source, and relative is from a point in the application, not your machine. Does anyone have any questions over that? Let's hear Andy.
For the relative example, you said the period is from the position that you're in already. Does it have to be, does the, I guess, what the address or whatever the following thing is, does it have to be within the location that you're in already, or can it be wherever the user is, you plug this in, copy and paste, and that's where it's going to go? Is that how it works?
So when it comes to how that works, it's going to be from wherever the file is being executed. So if I'm currently in this example one directory, right? But if I'm writing a relative path inside of my main.py, I wouldn't write it from here moving backwards. Or I wouldn't write it here moving into example one, right? I would say, hey, I have to go back to directories. Because going back one would put me at Installfest and going back two would put me at Avenger. And then I would be able to clarify the rest of this. Right? Because the file being executed is main.py. So it's in reference to where the file is being executed, not to the current location of the user. Does that answer your question, Andy?
Yeah, it answers the question. So I guess if you're sharing, if, for example, you shared that with me, I would have to follow the exact path leading up to that point for it to work on my machine. Is that what you're saying?
Right. The correct folder structure would have to be the same. Awesome. All right. Any other questions? Let's hear it.
I think I'm missing something basic here. What's actually being accomplished when you're putting that in to your code? Are you creating a file? Are you opening? What's the point of sharing that with someone? That line.
Yeah, that's a great question. If I were to share something where I am referencing like a CSV file, or I'm just referencing different files within one another, and I'm having import statements. So, for example, let's go ahead and do something like this. Main2.py. All right, and then go. I apologize, everyone. I'm gonna take off a little bit here to make sure that we have some information. And I do say hello. Print. All right, so here we see this say hello function, right? Well, I want to import it into this main.py. Well, I can say from period, main2. This is a relative path. I want to import, say hello. So my relative path is saying from this location, there is a file named main2. I want to import the function, say hello. So it's just for importing different functions, maybe importing different classes, or if you're sharing something like data that's happening within CSV files and you need to be able to reference them, you wouldn't want to write an absolute path because that would crash when you're sharing code with other people. Whereas if you have a relative path, that will always be flexible regardless of which machine it's being executed in. Does that answer your question, Dallas?
Yes, sir.
All right. Awesome. Any other questions? Okay, perfect. Let's go ahead and continue going down here. We already went over this make directory. We went over touch as well. CP, which is going to be our copy command. All right. So let's say that I wanted to have a copy of this main2.py inside of my Installfest. Well, what I would do here is I would run CP and name the source. The source that I currently have is main2.py. So that's the current location where this file lives. Now I would say where I want to leave this copy. I can make a copy inside the same file, or I can make a copy, I can make a copy inside the same directory, or I can dump a copy outside in the parent folder. Let's say I wanted to drop it in the parent folder. Well, I would go back out to the parent folder and then specify main2.py. And in doing so, now I get main2 on the outside. I could also make this copy inside of the same folder and just name it something different. I can say, hey, I want to make a copy of main2.py. And I want this copy to live inside of the same directory. But instead of naming it main2, because I can't have two files that are named the same, I want to name it something like copy of main2.py. And when I do so, I now have a file named copy of main2.py. You'll see the same exact code that was written in main2 inside of main2.py. Right, so everything was copied. All I did was change the naming convention because we can't have two of the same names. And that's the copy command. Let me go ahead and add that here. So CP current location followed by desired location slash desired name. That is going to create a copy of a file. All right. That's our CP command there. There's also the MV command, which can be utilized to move a file or to change a file's name. So for example, now that I made a copy of main2, I can change that file's name to be main3. I can say MV main2.py to be main3.py. And I just have to specify, hey, I want this to be within the same directory. And in doing so, you'll see M2 has now changed and is now M3. I still have this main2 on the outside. So maybe I can move it back inside of that example directory. Can anybody walk me through how I would do that? Other than Nick? You've gone quite a bit, Nick.
Could you repeat the question, please?
Yeah, I want to move the file main2.py inside of the example1 directory.
So you want to move main2.py to example one. Wouldn't that be? We're talking about the MV move command, right? So wouldn't it be move um, main2.py space? You target the example1 directory and just like hit enter, and it just sends it there.
Right. So here we have move main2.py into the example1 directory. And by doing so, you'll see that currently there is nothing other than the readme.md. And inside of example1, now we have main2, and main3 with the move command. All right, awesome. All right, so let's go ahead and write that here. We have the move command, which is, again, current location. And then we can put it into a desired location and desired name. This will move a file to a different location with or without a different name. All right. There's our move command. Let's continue moving forward here. Here we have our rm command. So in this rm command, we're going to go ahead and actually I'm going to show us a little bit more of the CP. I'm going to make a copy of example1, make an example2. So I'm going to cp-r. This -r means recursive of example1. And I'm going to create example2. Now this -r is necessary because I have a bunch of files inside of example1. If example1, the directory of example1 was empty, I would not need the -r. But because I have files, I need to have that -r so that I can copy everything inside of it. Now, same thing applies with rm. Now that I have an example2, I can change directories into example2. And here I can start applying something for rm, which stands for remove. I can rm copy main.js, and you'll see that that file is now removed. And if I wanted to remove the entire directory, well, I can rm-rf example2. And that would move that entire directory of example2. I'll answer this question, but I do have one more thing to annotate. Go ahead, Alex.
So if you didn't add the -r when you were trying to copy example1, would that copy just the folder itself without anything in it?
Let's try it. Yeah, let's go
Okay.
into copy example1, or excuse me, cp example1, and make it into example2. So it tells me, hey, example1 couldn't be copied. So it's a directory, cannot be copied. I can do cp-r, and that tells it, I understand this is a directory. I want to copy all of the files of example1 and also create a directory named example2. And that's when it actually works. Does that answer your question? Perfect. I see thumbs up. All right. Now, we just covered a command called rm-rf. Yes, this will remove a directory and everything inside of it. You need to be extremely careful with this command here. Because if I were to utilize this at the root of my machine, I am essentially deleting everything inside of my machine and just ending up with a shell that won't necessarily work or do anything for me, right? I would just be erasing my entire laptop. So please make sure that when you utilize this command, you ensure to add the folder every single time. Don't just execute this freely. Take a time, pause, make sure it's the correct folder that you're trying to remove. All right. Let's see here. All right.
Quick question.
Yes, go ahead.
Sorry, I guess I forgot to raise my hand. So if you were to do the rm-rf without putting in the folder, by accident, you hit enter, will you get kind of a warning as like, are you sure kind of thing? or is it just going to go through with it anyway?
Well, let's see.
Because I mean, I'm afraid to try it, so it's not really something I want to test.
It should give you an error because you're not passing what it is that you want to do. I'm going to do it inside of this child folder and see what it does. Yeah, so it didn't do anything. So if you do rm-rf, you're not telling it to remove anything, so it doesn't know what to do. So the command
Gotcha. Okay.
is successful, but it doesn't actually execute a function. Of
Copy. Thank you.
course. All right. Oh, and then right now I just made sure that I could read the rest of my terminal. I did that by pressing or by entering clear. So let me add that in here. Clear. I guess the easiest way to explain that is refresh this terminal. Input and output. We went into our M file. We'll remove a file. And then we also covered how rm-rf, name of directory, will remove a directory and all of its contents. All right. Now there's miscellaneous here, which we have sudo, clear. We're not going to go over links. Control C and Control D. Okay, those might be good to. We'll be covering Control C and Control D later on once we dive into servers. But for now, let's go ahead and cover sudo. There's not a practical application for sudo just yet. You will see it during Installfest. Whenever you're trying to install new things into your machine, or you're trying to execute something that will force write files into your machine, or you're trying to change permissions for a specific file so that it can actually execute its function correctly, it may ask you to give it the appropriate permissions. Now, in order for you to give any file the appropriate permissions, you may need to execute something called sudo, which stands for super user do. And then follow the command that you were trying to execute. A typical sign that you need to execute this sudo, it may say something like permissions required or permissions not authenticated. And I think in Node, the most common one you'll see is something like EA access denied. So if you get any of these messages, that's a sign that that command that you're trying to execute needs to be executed after the sudo keyword. Now, when you execute the sudo, it's going to prompt you to enter password. So you'll need to enter the password to your user, and that will actually execute the command at that point, or change the permissions for the file so that the file can actually execute successfully. All right. Any questions about anything that I've covered up to this point? Okay, perfect. It looks like everything else here, or the file navigation for taking a look at a file, we'll go over head, tail, and less. We will not be diving into Vim just yet, and we will not be diving into operators just yet. Those are going to be a little bit more advanced. We'll go ahead and take a look at those later on once we start actually working within the cohort and seeing some more exclusive files. Vim, we probably won't actually see it until we get to deployment. So let's concentrate into these. I'm going to go ahead and create a TXT file. Touch example or my text.txt. And in this my text.txt, I'm just going to write a bunch of lorem ipsum. Oh, I can't do that. All right. All right. So here's my file. I created a little bit of dead space. At the beginning, I have a bunch of gibberish. In the middle, I have hello Avenger. And at the very end, I have this is the end. Well, if I wanted to take a look at a file, but I didn't necessarily want to just click through it, I just want to be able to make a quick peek through my terminal. Well, I could do that utilizing this head command. I can say, hey, I would just want to see the very top of this file. Maybe I just want to check the import statements. I can say head my text txt. And you'll see that it'll give me the first few lines of code there. So we can see all of the gibberish that I had at the beginning. If I run with tail, and I then pass my body there, or excuse me, my name, it'll show me this is the end, because that's the very end of the file. And if I run less, it shows me pretty much my entire file in a more shortened up version. If I continue to press enter, it'll show me the entire file all the way towards the end. And then it'll say, hey, this is the end of the file. I can just press Q to enter that view version. Pressing Q on my keyboard stands for quit, and that's what will exit that functionality for less. Again, head lets me see the very top of the file. Tail lets me see the very bottom of the file. And less lets me see the entire file until I press Q. So once I see the information that I need to see, maybe I don't need to scroll through the entire file. I just press Q, and that quits my file automatically. All right. At this point, does anyone have any questions over anything that I've covered over our Linux commands?
Yes, are we going to learn about some of the shorthands also, versus just typing like the keyboard commands like Control L to clear a terminal?
We probably won't dive into all of them just because of time complex, or excuse me, time issues. If you want something like that, what we can do is we can find cheat sheets that have keyboard shortcuts and then start sending those inside of our resource channel. Actually, we'll get right on that. We'll just start sending out some cheat sheets for now. All right. Any other questions? Perfect. If there aren't any other questions, then let's go ahead and take a nice 12-minute break and go ahead and come back at 2:15 so that we can dive into our actual independent machine Installfest. Thank you so much, everyone. And I'll see everyone back here at 2:15.